Hello everyone, I am Sreenivasulu K N, Assistant Professor, Department of ECE-Nagarjuna College of Engineering and Technology. Today we are going to study about why we are exactly opting for digital circuits instead of an analog circuits. Before that, we have to know what do you mean by electronics. Electronics is nothing but the study of electrical circuits, which consist of different electrical components. So if I take few examples, what are different electrical components which are taken in electrical circuits are, so it is nothing but diodes, say transistors, MOSFETs, and clearly it is integrated circuits and vacuum tubes. Still we use different kinds of electrical components to made up of like different electrical circuits. Based on the usage of electrical components, electronics is being broadly classified into analog electronics and digital electronics. So in analog electronics, we use different components, say diodes, transistors, MOSFETs. So different types of passive and passive and the active components. So we broadly classified these passive components as resistor, inductor, capacitor, and whereas the active components are say diodes, transistors, MOSFETs. So if we come towards the digital electronics is again the sub branch of electronics where we study based on the usage of a very fundamental block called as integrated circuits. In integrated circuits, we usually go with the gates. So in gates, we have different kinds of gates. So along with that, we have flip-flops, latches, counters, and we have many. So these usage of electrical components compromise digital electronics. So if you take the difference between an analog and digital electronic is the type of input signals also. So if you just observe, this is a type of an input signal which is given to the analog circuit. So which varies continuously with respect to time and which gives a voltage value, which completely. So we just take it as plus V and minus V. So whereas if we go with respect to the digital electronics, the input is just zeros and ones. So this is the input which is being with respect to time, and here we get with respect to voltage. So the major difference is here it will have just plus 5 volt or the 0 volt. So we say plus V and the 0 volt. This is a major difference between an analog electronics and digital circuits. So now why exactly we are opting for digital electronics is there are few reasons. So that we just take it as an advantages of the digital electronic circuits. The first major advantage is the digital electronic circuits are noise immune circuits. What is the meaning of noise immune is nothing but the signals will not be affected by noise. Whereas the analog signal, it will be interfered with noise. Again, we won't get the complete output. So this is the first big advantage. Second is it is highly programmable. So all the digital circuits are completely programmable when it is compared with respect to the analog circuits. Third one is it is easy to store. So easy to store and also easy to design. So the basic thing why it is easy to store is only the input will be in the form of zeros and ones. And why it is easy to design is the complexity does not vary much. And the last is the high accuracy. So these are the major advantages which will make us to go with respect to the digital circuits rather than the analog circuits. But we have few disadvantages also. So in that we will list out a very major disadvantages of digital circuits. So why exactly with there are some issues or there we say some conditions where we can't go for digital circuit is first is Since it is easy to design, but the another major disadvantage is the cost of a system is very high. So when it is compared, we can get all the electronic and electrical components for a very less price. Whereas if we go with respect to the ICs, say the flip-flops, or let it be the latches, counters, registers, the cost completely varies high when it is compared to with respect to the analog components. Next is because of the analog nature of the output of real-time world. We say this because whatever the output, it should be readable by the user, which is nothing but the end user. I can't keep my output in terms of zeros and ones, and so that it can't be readable. So if it has a perfect say, let it be on or off, so it should have some kind of a meaning where the end user can easily understand why we are going, what is the output of that particular system. So based on this, these are the advantages and disadvantages of digital circuits. So next is in digital circuits. So there are broadly, we classify, there are two different types of digital circuits. So one is combinational circuits, and another one is the sequential circuits. So what is combinational circuit and what is sequential circuits is nothing but in a very simple way. So I'll just take a small block diagram. So this is a system which requires two inputs, input A and input B. So I'll write it this as input, and whereas it gives out the output, say Y1 and Y2. So this is a combinational circuit. So whereas if we go with respect to the sequential circuit, so I'll write it as so it also has say few inputs. So I'll take this as inputs. It will have another important component called clock, and it has outputs. So the important another thing is there is a feedback to the circuit. So if you just observe these two blocks, we have a clear differentiation between the combinational circuit and the sequential circuit. This combinational circuit here, whatever are the inputs, it will completely be processed and will get the outputs. So the outputs will not depend anything about the previous inputs or the outputs existing. Whereas if you see with respect to the sequential circuit, it has inputs. Additionally, it has a clock, which is a time varying signal, and you also has a feedback from the output, which will be taken as an input. So these are the things which are processed and in a particular circuit, and we'll be getting an output, say Q and Q bar. This is a very simple and a major difference between a combinational circuit and the sequential circuit. So if I say the examples, so the simple example is half adder and full adder are the combinational circuits. So if I just take a half adder, so here if I take it the inputs, so half adder is a combinational circuit where it will add two bits. So we'll take two inputs, input A, B, and we'll be getting two outputs, which is sum and carry. So whereas if I take an example with respect to a sequential circuit, I'll take a small example is SR flip-flop. So if you see here, there are two inputs, S and R, and you will have another input called clock, and also you have a feedback from the output. So this is Q and this is Q bar. So in this way, the kind of the feedback which we are getting will be made use of it, and it will be taken as an input and it will be given to the sequential circuit. So with respect to the combinational circuit, so whatever is the input, it will be just taken, processed, and will get an output.